Good afternoon to all. Screen is visible to you?
Yes, sir.
Okay. So I am Dr. Kamal Lochan Mohansen. So I will take today's class because your teacher is in leave now today. So sir have discussed.
Sir, momentum and elastic and
Okay, impulse momentum theorem. Impulse momentum
yes, sir.
parts I have already done. No? Okay. So exercise problems are done.
No, sir.
Okay. Then whatever test your understanding at the example. Just I will show you, so you will check it that is I have covered or not. Then whatever remaining thing is there, we'll discuss. Okay. Just to this problem, example 8.9, sir have done probably this thing just to check it. This thing, a 1000 kg car traveling north. This one. Hello. See the question and tell. See, sir have done.
No, sir.
Okay, we will start
Yes, sir.
from
Yes,
here.
sir. This is done, sir.
Done,
This is
sir.
done.
Done.
This is done, na? Okay, good. Okay, the exercise 8.5.
No, sir.
No, okay, we'll start from here. Okay. So all of you have to note down this question, and you have to solve it. You will check that thing is correct or not. Okay. So this is exercise 8.5. One 110 kg football lineman is running to the right at 2.75 meter per second, while another 125 kg lineman is running directly toward him at 2.60 meter per second. What are the, you have to carefully see the direction, according to that you have to solve it. Okay. What are bit A, you have to calculate the magnitude and direction of the net momentum of these two athletes, and bit B, their total kinetic energy. So you know the formula for the momentum and the kinetic energy. So any problem is given to you. So first what you have to do, you have to identify, set up, then you have to execute. Okay. If that is a easy question also you have to do. Then by that way there is no mistake will come. So here a given thing is that what? Mass of the lineman, that is A. You can take that is 110 kg. It is given. Mass of the lineman B, that is 125 kg. So velocity, this is relating to the x direction. So you can take that is Vax is equal to 2.75 meter per second, and Vbx is minus. Why minus? Because opposite direction. So minus 2.60 meter per second. So now you know the formula, that is momentum P is equal to mv, but here relating to the two bodies, so two mass, two velocity. So you can use Px is equal to ma Vax plus of mb Vbx, then you put the value, so you will get the momentum. So do it. because if multiple choice question, so answer should be given in the but maybe one is in positive, another is in negative, and any other two option will be there. So you have to choose the correct answer. Okay. Do it quick. Got the answer? Yes. How much momentum you have got it?
minus
Minus? Tell.
So 3.5.
3.5 momentum, no. Those who have calculated, you raise the hand, okay? Ankit, tell the momentum first.
Sir, minus 22.5.
You have to tell the unit also,
And
minus
the kg meter per
22.
second.
Okay. But actually, you have calculated, that's right, but according to question, that is not correct because Asutosh tell,
Minus 22.5.
but question is what? BTA question is You have to calculate the magnitude and direction. Magnitude means you have to tell the 22.5 kg meter per second. Okay. Otherwise, you have calculated, that is right. And what is the direction?
Sir, means we have to show it by vector notation.
No, direction you can write. Direction, it is directed towards the left. Okay. But magnitude is
Yes, sir.
22.5 kg meter per second. Yes, other people quick do. And those who have completed, you go for the total kinetic energy. You have to involve yourself and you have to solve it, you will get the correct answer. Aditya Narayan, done. Nikita, Subhash Mandal. Tell your answer. Those who have completed, you go for the total kinetic energy. How will you get the kinetic energy? Because here two bodies, so one will be half of MAVA square, another is half of MVB square. Okay, so you add both, so K you will get it, total kinetic energy. Okay, Saswat have done good. Other quick do. Asutosh, you have got 838.437 joule.
Yes, sir.
You have to check again.
Yes, sir. 838.4375.
It is coming.
Yes,
Yes,
sir.
sir.
Okay, check. If it is coming, that's nice. You put the value, whatever coming, you write it. Okay, 838 is the correct answer. Okay, whatever 838 point something is coming, that is correct. All right, you can near equal to 838 joule. You can take it. Anissa, you write the unit also. Okay, you are not writing the unit. Anywhere you are doing something, you have to write the unit. Aisha, done? Okay, so K is equal to half of MAVS square plus of half of M VB square. So this is half, and MA is given 110 kg into MB is given 2.75 meter per second square plus of half of this is MB is given 125 kg into this is 2.75 2.60 meter per second square. This is minus, so you can square it. It is plus, so it is coming 838.4 joule. Okay, this is not 8.3. This is 838.4 joule. All of you do it. These are very important questions for the examination. Those who have completed both the bits, you raise the hand. Except that minus 22.5 kg meter per second and direction is left for the momentum, and for the kinetic energy that is 838.4 joule. If any other answer near equal to 838 joule, if anybody is getting, that is the correct. If other answer you are getting, it. Harish, tell your answer. Harish. Harish, you can directly reply. Okay, if all of you have completed, we will go to the next question. So all of you write the question first, then you have to solve it. Okay. So question is, a 68.5 kg astronaut is doing a repair in space on the orbiting space station. She throws a 2.25 kg tool away from her at 3.20 meter per second relative to the space station. With what speed and in what direction will she begin to move? So write the whatever the conservation momentum formula you apply it, then you solve it and to get the answer. Question is visible to all?
Yes.
Okay, do quick. These are very important questions for the examination.
So body has two types, one is regular and the regular shape. So regular is rectangle, square, sphere. So these are all regular because by geometry you can find out the surface area for the everything you can calculate. But for irregular shape, like a piece of stone, then it is a irregular shape. And in this irregular shape, you put up to one for mass. You understand what I'm saying? Center of mass center of mass is a point at which the whole mass of the body is concentrated. That is the center of mass. So let us start with this topic. Rigid body is an idealization of solid body.
Doing? Very simple. So we have to consider A be the lead astronaut and B be the tool. So if you will take the positive x direction in which she throws a tool, so initially it is at rest. So VAX equal to VB, VA1x you take and VB1x is equal to 0. Astronaut is initially at rest. Then she throws a 2.2 kg tool away from her at 3.20 meter per second. That means here VB2 x is equal to plus 3.20 meter per second. So now we have to apply the conservation of momentum to the system of the astronaut and the tool. So we'll get the total momentum before the collision. We know that is equal to total momentum after the collision. This is which type of collision?
Elastic.
Elastic.
Okay. What are the different type of collision? Tell?
Elastic and inelastic.
Okay. Any other type is there? Another is completely. Tell. Completely inelastic collision. So when we will tell one collision will be completely inelastic collision? Tell already in the theory part you have read it.
Where the loss of the kinetic energy takes place.
And the two body are
They do not transfer energy with each other. Remain same. No, both loses equally.
anybody? And the two bodies stick together. Yes or no?
Yes, sir.
Yes. So here the total momentum before collision is equal to total momentum after the collision. So MA/VA1x is equal to MB/VB1x.
Momentum get conserved in inelastic, completely
Yes.
inelastic.
So here VA, MA/VA2x plus of MB/VB2x. Now you put the value. So because MA1x and MB1x is 0, so MA will get MA/VA2x plus of MB/VB2x. So our M is what we will calculate. We have to get the with what speed, speed means velocity, that VA2x we have to calculate, and what direction it will. Okay, so from this you can get, you simplify it, you will get the VA2x. So VA2x is nothing but this will be minus of MB/VB2x divided by MA. MB is given, that is 2.25 kg into VB2x is 3.20 meter per second divided by MA. MA is 68.5 kg. So it is coming minus of 0.105 meter per second. So here the speed is 0.105 meter per second, and she moves opposite to the direction in which she throws the tool. Okay. So quick do. Write the formula first, then you put the value, then you proceed. Okay.
So this is the reference you want to write a kinematic equation.
How much answer you are getting? Anis, I have got it. Okay, Anisa, this is a good, correct answer. Other people do quick. After completion, you raise the hand. Asutosh, what is your answer?
Sir, minus 0.105 meter per second.
Okay, good. Swayam Jati?
Yes, sir. Same answer.
Okay. Harish, same or any different? Ankit?
It's the same answer.
Okay, good. Other quick calculate. So answer will be VA 2x is equal to minus of MB BB 2x by MA. So MB is given 2.25 kg into VB 2x is 3.20 meter per second divided by MA is 68.5 kg. So answer is coming minus of 0.105 meter per second.
Acceleration. You can change in angular velocity by changing that. Every time we use J, the average acceleration, real axis can be calculated. Every axis of rotation. So we take J, factor J minus omega 1 J minus 2 and for instantaneous, you can write that.
So completed, we will go to next question.
Yes, sir.
Okay, good. So question is a 15 kg fish swimming at 1.10 meter per second suddenly gobbles up a 4.50 kg fish that is initially stationary. Neglect any drag effects of the water. Beta find the speed of the large fish just after it eats the small one. It be how much mechanical energy was dissipated during this meal. So sometimes you're observing that. So if we were observing in a phone, so one big piece is there, small piece is there. So big fish is eating to the small fish. That situation is here.
axis theorem, parallel axis theorem, and perpendicular axis theorem, then moment of inertia calculus. So let's get you to write it down.
Ashutosh done this question?
Sir, first bit I have done.
Okay. How much you have got it?
Sir, 0.846153.
0.846153.
53. 846 then. Sir means recurring is occurring. Yes.
Okay. You need to tell?
So meter per second.
Yes. Always you have to write in the proper unit. And do the second one. Other quick do.
So x and y is perpendicular to each other, and x, y, z are mutually perpendicular to each other. Any axis can be taken. You can take x.
Other quick do and raise the hand.
Any axis that perpendicular axis theorem. And another one is called parallel axis theorem. Parallel axis theorem.
The other quick do. Quick do.
Done, sir.
Done. Second answer is how much?
Sir, 2.097.
2.097. Yes, good. Correct answer. Because this is 2.10, you can take it.
Yes, sir. It is rid of to 2 decimal.
Yes. Whether you are not doing or what? Taking so much time. Okay, I am explaining. After that you will do. So mass of fish is 15 kg and mass of how much it is given? Just a minute. This is given. One piece is given 15 kg and another is 4.5 kg. Okay. Okay, so mass A of fish, one piece you are taking, let. So mass of the fish A is 15 kg and mass of the fish B is let 4.5 kg. So in the positive x, the that initial direction of fish A, that is BA1x is how much? According to question, that is 1.10 meter per second. And BB1x, that time that is another fish in the rest, so BB1x is equal to 0. So again, we have to use here the conservation of momentum, that formula. So after collision, the two bodies are combined and move with the velocity v2, because the first phase is the second phase. Okay, the total momentum before the collision is equal to total momentum after the collision. So you can take for first V, that is PA the momentum, and second it is the PB the momentum. So PA plus of PB before collision is equal to PA plus of PB after collision. So MA, so PA is equal to what? MA VA1x plus of MB VB1x, so it's equal to MA plus of MB V2x. So second body is in the rest, so you can take PV1x is equal to 0. So here MA VA1x is equal to MA plus of MB V2x. So V2x is equal to, we'll get MA VA1x divided by MA plus of MB. Okay. So first piece mass is 15 kg. You put here MA VA1x is 1.10 meter per second divided by MA is 15 kg plus of MB is 4.5 kg. So is equal to 0.846 meter per second. So all of you have got the first bit answer. So for the find the speed of the large piece, just after it it's the small piece. Okay, that velocity is cam how much? 0.846 meter per second.
So our theory part is covered. Again, I repeat our theory of the beginning of the rotational motion. You have theta is equal to angular displacement. So we write the angular displacement is reverse into angular displacement.
Then we will go for the kinetic energy. Okay, so kinetic energy before the collision is equal to K1 half of MA VA1 square plus of the second one is 0. So half of M VA1 square is equal to half of MA is 15 kg into VA1x is 1.10 meter per second square. So it is coming 9.08 joule. Similarly, kinetic energy after the collision, that is K2. K2 is equal to half of MA plus of MB V2 square is equal to half of MA is 19.5 kg into 0.846 meter per second square V2. It is coming 6.98 joule. So the mechanical energy dissipated, that is K1 minus of K2, that is 9.08 joule minus of 6.98 joule, it is coming 2.10 joule. So from this we can know that now the total energy always decreases in a collision where the two objects become combined. So combining, so the total kinetic energy always decrease. All of you write these things, very important question for the exam.
Then you start our problems. So one question that you will solve calculate the moment of inertia. This is 9.59. It is your good question. Calculate the moment of inertia of a uniform solid base out of mass m and the radius r of an axis perpendicular to the plane of the base and passing through a cell. The diagram is
And Achyut done? Achyut Chaudhary, done or not? Achyut Chaudhary. Yes, Achyut Chaudhary. Achyut Chaudhary. Okay, you take some time and you to do it. So all of you have got the answer? Got it?
Yes, sir.
Okay, so one last problem is there. We'll go to that. These are very important questions for the semester exam. This is the last one. Okay. Exercise 8.47. Okay. A 0.15 kg glider is moving to the right on a frictionless horizontal air track with a speed of 0.8 meter per second. It has a head-on collision with a 0.3 kg glider that is moving to the left with a speed of 2.2 meter per second. Find the final velocity, both magnitude and direction you have to tell, of each glider if the collision is elastic. So this is the situation shown. A is a body, B is a body, A have the mass m equal to 0.15 kg and mb is 0.3 kg. This is before collision. So velocity va1 va1 is 0.8 meter per second, vb1 is 2.2 meter per second. So you have to calculate the final velocity, magnitude and direction of each glider, that means A and B, if the collision is elastic. Quick do. All of you are observing the question? Yes or no? The screen is visible. Why you are only writing? You have to tell directly.
Yes, sir.
Okay, okay. Only Asutosh is active. Huh? And Harish is writing in the chat. But other
Yes, sir, writing.
writing. Okay, good. Sudhanshu, do it. Because aim is that all you have to actively do it. Because this is the online, that's why not I am able to see all of you. But that is your responsibility. Which thing I am telling, that is for all. It's not one to people.
What I want actually to know the tricks. This trick is if it is a base, that's why I go with mass for area into area. Suppose if I ask you to find out the same problem but in the sphere, but in the sphere. So can you solve this
After getting the answer, you tell.
Sir, minus 1.2 meter per second.
Minus 1.2 meter per second. For each glider. Asutosh have got VA equal to 3.2 meter per second. Direction is left. VB is 0.2 meter per second. Left. Who have told that minus 1.2 meter per second?
Sir, I am checking that again. That was wrong.
No, I'm not telling that is wrong. So I'm just asking. What is your name?
Sir, Swam Jyoti.
Oh, Soyam Jati. Okay, good. Do it. Check it. What that result is coming. I have to check it. 3.2 and 0.2. This is the correct one. Okay. Whatever. Whatever that Asutosh have done it. This is correct. Ankit. VA equal to that is not minus, okay?
Angle covered by A is the at any point of time T, given as T is equal to 4 PQ minus 2 square plus 5T plus T. We have the total acceleration at T is equal to 0.8 seconds. Radius of the path is 7 meter. And the angular acceleration.
Why only 1-2 people are actively doing, other do quick? Ashish Sahu have done 3.2 meter per second. Okay. And VB 0.2 meter. Good. Ayushman, what is your answer? Ayushman Nayak. Bhumika Jena, done? Manish, so what is your answer? Upasana? Okay, those who have not done, just check it. Okay. So from the conservation of x component of momentum, so we know that MAVA1x plus of MBVB1x is equal to MAVA2x plus of MBVB2x. So MA is given here 0.15 kg and VA1x is 0.8 meter per second. So MB is given 0. But direction is opposite. This is given MB, just to see. This is the MB 0.3. So into VB1 x is 2.2 meter per second. So is equal to, this is MA 0.1 kg, VA2x is, we have to calculate it. Then this is 0.3 kg. This is minus of 0.5. So you have to simplify it. So from here, VA1x and VB2x calculate. So VA2x plus 2 VB2x is equal to minus of 3.6. From the relative velocity equation for an elastic collision, VB2x minus of VA2x is equal to minus of VB1x minus of VA1x. So this is coming 3 meter per second. Okay. So VB2x minus of VA2x is 3 meter per second. So now these two equations, just you see here VA2x and here minus of VA2x, and here 2B, but 2 VB2x and this is VB2x. So you have to solve these two equations. So by solving these two equations, so you will get VB2x is coming minus of 0.2 meter per second, and the VA2x is coming, that is minus of 3.2 meter per second. So directly, because according to question, our we have to calculate the final velocity, that is magnitude and direction of each glider if the collision is elastic. So we've got here the 0.5 kg glider is moving to the left at, this is the magnitude. Magnitude means you can take, that is 3.2 meter per second. Similarly, for the second, the 0.3 kg glider is moving to the left at 0.2 meter per second. So those who have not done, you just write down this thing. All of you understood? This is all about the exercise problem of the chapter 8. If question will come in exam, you will able to do it. This exercise problem.
Yes, sir.
Okay. Those who have not done, you just write down. Just momentum conservation, you have to consider it. You have to put the value, and two equation you will get it. These two equation you have to solve it. So you will get the value.
Angular velocity at t equal to 0 given. Angular velocity at t equal to 0 given means that is your omega 0 z. Omega 0 z is given 47.5. Okay, so angular acceleration is given minus 10.
So written that Vbx is minus 0.2 meter per second, Vx is minus of 3.2 meter per second.
You understood from here directly?
So Anisha, what you are getting? One is 0.0005443. What is that one? Anisha? Okay, all of you have got the answer. So this is all about your exercise of the chapter 28. Okay. So already it is time, so we can stop now. So thank you all for your patience. So now you can leave the class, okay?
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you. You have another class now? Or?
Yes, sir. We have another.
Okay. So you stay, I'm leaving. Okay.
Hello students, good afternoon to all of you.
Good afternoon, ma'am.
In the last lecture,
Good afternoon.
matrix, right? Matrix representing relations.
Yes, ma'am.
Yes, ma'am.
So this example was done.
Yes, ma'am.
I gave you one
Yes, ma'am.
exercise. What is M matrix
S.
cross
So S.
R composition S? This was exercise given. So did you try this one?
Yes, yes, ma'am.
What is that matrix coming? Can you tell me?
Ma'am, 110000101
110
000
000 then
101.
101. Everyone is getting the same? Yeah? What about others? Did you try? Tried or not? Anyway, let me check.
Same answer.
Same answer. Okay. You are getting the same answer then. Good. Corresponding to r raised to power n, this will be n times Boolean product, right? Of the matrix. Now come to 6.12. Find the matrix representing the relation R2, where the matrix representing R is given as this one. What you will do? You need R and R square, right? R square is what? R composition R, right? R composition R. Yes?
Yes, ma'am.
So MR composition R, this will be MR Boolean product with MR, right? So just take the Boolean product with the same thing.
Yes.
You will be getting matrix representing with, that is the car of that. Okay? So just try to find, are you getting the same answer or not? So it will be 0, 1, 0, 0, 1, 1, 1, 0, 0. Tell me. Operations, tell me. Yes? Operations.
Ma'am, 0 conjunction 0.
0 conjunction 0, disjunction with 1 conjunction 0, disjunction with 0
0
disjunction
conjunction
1. 0 conjunction 1. So it will be 0 disjunction 0, disjunction 0, right? So that is coming as 0.
0.
This one with this one, we have 1 1 at second position, right? That will giving you disjunction with 0 0 and 1. This will be giving you 1, and here again 1 we have, so it will give you 1. What about this one? At third position, we have both are having 1, so it will give you 1, right? And here 0, 1, 1, 1. 1, 1 give you 1, so disjunction will give you 1, right? And again, at the second place, you have 1, so this gives you 1. What about this one? 0, 1, 0, 0, 0, 0, right? Then 1, 0, 0, 1 at first place, 1 at first place, this gives you 1, right? And here 1 0 0 1 0 0 0. Correct?
Yes, ma'am.
How many non-zero entries does the matrix representing the relation R on? R is defined on this set 1, 2, 3, and so on up to 100. Okay, where R is the set is consisting of first positive 100 integers, so this is given. Non-zero entry. A matrix representing R contains either 0 or 1, right?
Yes, ma'am.
Clear? So you will be counting just ones, number of ones. Okay. So
Yes,
first
ma'am.
relation is given as A and B are related if A is greater than B. So relation on given on this set. Cardinality of A is 100. What is the order of MR? MR will be
100 cross 100.
100 by 100, right? Yes, for the first relation, here 1, 2, 3, 4 and up to 100, 1, 2, 3, 4 up to 100. If 1 is related, it will give you 1. 1 is not related, it will give you 0. That is, I is related to j, then its ijth entry will be 1, otherwise 0, right? Or you can just say A is varying over here, B is varying over here. A is related to B, then 1. A is not related to B, then 0, right? Tell me for this relation. AB, A is greater than B. At diagonal entries, you have A is equal to B. Or you can say I is equal to J, right? At diagonal entry, it will be 0, 0, 0 for this
0.
one, right? So diagonals are zeros.
Yes.
0, 0, 0, and so on, 0. What about above diagonal entry? Here A varies, okay? And here B is varying. B is varying from 1 to 100, A is varying from 1 to 100. Yeah. B is greater than A or A is greater than B? What is it? Here A 1, 1, 1 comma 1, not related. 1 comma 2, A comma B. So A is less than B above diagonal, right? Above diagonal, you have A is less than B. Clear? Are you getting it?
Yes, ma'am.
Above diagonal, you have I is less than J. That's why A is less than B. And below diagonal, you have A is greater than B. Okay? So, what is the relation? A is greater than B. So, below diagonal, you have 1, 1, 1, 1. Right? Clear? And at diagonal, you have A is equal to B. So, what you will count? In the first row, how many ones? How many ones? A2, 1, 1. In the third row, number of ones is 2, right? Fourth row and so on up to 100th row. In 100th row, it will be 99, 1 and 100th place is giving you 0. Clear? So how many ones are there?
Yes, ma'am.
In second row, 1. In third row, 2. In fourth row, 3. And so on in 100th row, 99. Clear?
I'm in fourth row 3.
Yeah?
In fourth row 3.
Number
Achha,
of ones are 3.
Yes,
Yeah.
ma'am. Yes, ma'am. Got it.
Got it?
Ma'am, it
Because
is
main
second
diagonal is
row. You were telling first row 1.
first row 0.
Yes, ma'am. Ma'am, you said first row 1. So,
Oh, by mistake, I just said. So it will be in first row, it will be 0, na? That's why I didn't write.
yes, ma'am.
Second row 1, third row 2, fourth row 3, and 100th row 99. What is the sum? Yeah, 99, right? Divide by 2, S by 2, right? That is N by 2, sum of AP into A plus L, A plus last term, first term plus last term, 100. Right? So this is giving you 4950. Clear?
Yes,
Yes,
ma'am.
ma'am.
Or let me tell you regarding matrix. If you have n by n order, okay. Here n square entries will be there total, right? Total entries are n square, n by n. Okay. In out of n square, n are diagonals, right? On the main diagonal, n entries. Okay. Above diagonal, it is remaining is what? Above diagonal and below diagonal, right? So n square minus n are equally distributed over above diagonal and below diagonal, right? So above diagonal and below diagonal each having n square minus n by 2, or you can just say n into n minus 1 by 2. Okay.
Can you repeat?
And this saying, total number of entries are n square in matrix, right? A11, A22, 2 and so on, A1n, A21, A22 and so on up to A2n and so on, AN1, AN2, ANN, right? Total number of entries are n square, right? Out of n square, how many diagonal? A is equal to B or I is equal to J, n, right? A11, A22, A33, A44, ANN, right?
Yes, ma'am.
Out of that, n are diagonal. Okay. Plus the remaining entries are what? N square minus n, right? Remaining entry above diagonal plus below diagonal, right? What
Yes,
is
ma'am.
it? N square minus n. And you know that these are equal in number, right? These number of these is equal to the number of these, right? So what about the above diagonal? N square minus n by 2 plus below diagonal n square minus n by 2. Clear?
Yes, ma'am.
Yes, ma'am.
So that's what I wanted to. Or in general, you can just say n into n minus 1 by 2 below diagonal. And so same for above diagonal. N into n minus 1 by 2. And if you include diagonal in either of these one, if you didn't include diagonal in below diagonal or above diagonal in one case, then it will be n into n plus 1 by 2. N will be added right here. So if you solve it, it will be coming as n into n plus 1 by 2. Okay?
Yes, ma'am.
So only below
Yes.
diagonal or above diagonal, this one. Included, diagonal included, number of entries are this one. Okay, total entries n square. Except diagonal entry n square minus n. Okay, and same for this one, below diagonal you have and 100 into 100. So that is 100 into n minus 1, n into n minus 1, 99 by 2, right? That is coming as same. Okay? Clear? Now, what about second relation? So how many ones are there? 4950, right? These are non-zero entries. Okay? Means how many entries will be there in this one? Yeah. Am I audible?
Yes, ma'am.
Is there any doubt?
No, ma'am. Ma'am, I am telling the answer, ma'am.
Okay. Okay. See, number of ordered pairs will be this one only, right? Or they can ask you what is the cardinality of this set? Same for this one, right? Cardinality belongs to that is regarding we have 1, right? Cardinality is related to 1, where we have A is related to B. Yeah. What about B? A comma B, where
9,900.
9900.
9900. You have except diagonal, everything else is there, right? At diagonal we have A equal to B, and at non-diagonal entries A not equal to B. This means at diagonal we have 0, otherwise 1. So it is n square minus n, right? 100 square minus 100. This will give you 9900, right? Or you can double it up. You'll be getting the same answer, right? Clear? The cardinality of this set, or you can just say number of non-zero entry in the matrix, corresponding matrix is this one. For this one, A comma B says that A is equal to B plus 1. A is equal to B plus
Ma'am,
1 means
98.
A is 1 greater than B, right? And at diagonal, you have 0, 0. At above diagonal, A is less than B. So here also 0, 0. Here 0, 0. Only at 2, 1. 2 comma 1 is related, right? 2 is equal to 1 plus 1. 3, 2. It is related. What about 3, 1? Is this related? 3 is related to 1? No. 3 is equal to 2 plus 1, right? According to relation. So just below the main diagonal, it will be having 1, 1, 1. Otherwise, 0, 0, 0 everywhere. Okay? Are you getting it? Yes?
Ma'am,
See,
please
A is
tell
equal
again.
to A is equal to B plus 1, right? So here A is running, or I, corresponding to I we have A, corresponding to columns we have B. So at diagonal we have A is equal to B. Just below the main diagonal, diagonal below the main diagonal, we have A is 1 greater than B, right? Above the main diagonal we have A is 1 less than B. Okay, means to say, corresponding to this entry we have 2 is related to 1. Look at this A. A is 1 plus B plus 1, right? And corresponding to this one, we have 3 is related to 2. Clear? Look at this A. 3 will be 2 plus 1, right? What about this entry? Why this is 0? Because at this place, 3 is related to 1. So is 3 related to 1 according to this relation? A is equal to B plus 1. 3, if this is related, you are saying 3 is equal to 1 plus 1. Is it true? 3 is
No,
not
ma'am.
equal to 1 plus 1. That's why here 0. Here 0, 0. So just diagonal, below the main diagonal, it will be having 1, 1, 1, 1 up to here. Right? So as again, it starts with is equal to 2 to 100. Right? So it will be at second we have 1, at third we have 1, at fourth we have 1, at 100th we have 1. Right? Position is second to 100. Right? In second row, we have 1, 1, third row, fourth row, and R100 row, right? So how many non-zero entries are there? Or you can just say, what is the
99.
cardinality of this set?
99.
99. Everybody clear? Yes?
Ma'am, you are not audible.
I am not audible. To everybody or to
Ma'am, it's fine. It's
Ma'am,
fine
you
now.
are
It's fine
audible.
now.
99 or 98?
99? It is 99.
The
Starting with
first and last
2.
are the
Last is there. See, in last, what is happening? 99, 100, 99. Right? 100 row. So let me give you all the entries for this relation. So corresponding to this one, you have 2, 1, 3, 2, 4, 3, 5, 4, and so on, 100, 99. Right? 100 is equal to 99 plus 1. So this is also there. So starting with 2, 3, 4, and so on, 100. What do you got?
okay, ma'am. Clear.
99, na? Clear? Or you can just look at B and count it. It is again coming as 99. Now you got it?
Got it, ma'am.
What about D part?
100.
A comma B, thus that A is equal to 1. So let me replace A with 1 only, because A possibility of A is 1 only, right? 1 with B. 1 with 1? Yes. 2 with 1? No.
Yes, ma'am.
Right? 1 with 2? Yes. 1 with 3? Yes. And so on up to 100. 1 with 100. 2 with 1? It can't be 2, right? It can't be anything else except 1. So that's why everywhere else it will be 0. Right? How many entries?
100.
100 entry, right? Only first row. Clear this one? A is running from 1 to 100 and A
Yes, ma'am.
is fixed as 1. That's why all non-zero entry are 100. Or you can just say cardinality of this set which is 100. What about E part?
1.
1.
1 only? Because here we have positive integer
ma'am.
only, right? 1 to 100. So this is AB is equal to 1. The product is 1 possible only for A is equal to 1 and B is equal to 1. Both are 1, right? AB is 1. This means A is equal to 1 and B is equal to 1. Nothing else, right? So A11, that is at 1 1 we have 1, otherwise 0. Okay? Clear?
Yes, ma'am.
100 by 100. So number of non-zero entries is 1. What is the cardinality of this relation? 1. Right? Cardinality of the set you can say 1. And what is it? 1 comma 1. Nothing else. I hope everything get clear. All 5 parts. If still you have any doubt, you can ask me. No? Okay. Now come to this exercise. MR matrix related to this relation is given by MR. Find the matrix representing R inverse. This will be R complement and R square. Yes, corresponding to R inverse. What can you say about matrix representing that one? R inverse. Have you defined R inverse? Yeah. Have you defined R inverse?
Yes, ma'am.
Tell me the definition.
Adjoint are
Ma'am,
determinant are.
Yes.
adjoint is a determinant of it.
R inverse relation definition, not adjoint and anything else. If R is the relation from A to B, what about R inverse?
Ma'am,
It will
R
be
inverse will be the relation from set B to A.
B to A, and ordered
Such
pair will
that
be B
ordered
comma
pair
A,
be A. Yes, ma'am.
where
A,
A comma
B belongs
B
to R.
belongs to R. Good. This one, right? Now, if A comma B present in R, B comma A is present in R. Means I is related to ijth, mijth is 1 in R, MR, then mjith will be 1 in MR. Clear? If corresponding
Yes,
to
ma'am.
ijth entry is 1 in MR, then jith should be 1 in R inverse, right? So you just change
Yes.
this matrix to transpose.
Yes. Yes, ma'am.
Okay, ij to ji, and this comes when you take the transpose of this matrix. So MR inverse will be representing the transpose of MR. So no adjoint, nothing, only transpose of this matrix. Clear?
Ma'am, if we find through adjoint by a determinant of A, we will get the same answer.
See here we are using Boolean operations, right? So you might get the same answer or you may not get the same answer. It's up to, so just calculate it by using adjoint or SOP. If you are getting the same, then obviously it will be right.
Yes, ma'am.
What is the determinant of this matrix? You need determinant for that, right?
Yes, ma'am.
What is determinant? Yes?
The -2.
-2. So you will divide by -2 something, right? So that is not acceptable here. Only 1 and 0. Clear?
Yes, ma'am.
Yeah. What about transpose? Not transpose. Transpose is just MR inverse is the transpose of MR. That is Mij become Mji. Yeah. Complement. MR complement. How you define the complement relation?
Maybe we will interchange 0 and 1.
Is it 0 and 1? You are okay. All those elements which are not present in relation, right? AB says that AB is not present in relation, right? A and B are not related by this one. So AB are related via relation R, then it is not related by complement, and if it is not related, then it will be related. So you are correct. 1 is replaced by 0 and 0 is replaced by 1. Clear? So MR complement will change 1s to 0s and 0s to 1 MR, right? So here in 3 places only it will be 1, otherwise 0. Clear? What about MR2? Calculate it. MR square. Calculate it.
Ma'am,
1 1 1 1 1 1 and 1 1.
ma'am, all are 1.
All are 1, right? That is MR. Boolean product with MR, you can calculate it. Everything is getting 1. Means R complement contain A cross B. All, right? Here you are having Rn and R2 are relation in set A, representing the relation. Matrix representing the relation are given as MR1 and MR2. Find the matrix that represent R1 union R2, R1 intersection R2, R2 composition with R1, and R1 composition with R1, and R1 XOR operator with R2. What about MR1 union R2? Yes. How you calculate MR1 union R2?
Ma'am, join of the matrices.
Join and intersection meet, right?
Yes.
Join of two matrices will be
0 1 0
0, 1, 0,
0
right?
1
Then
1
And
1,
1, 1.
1, 1,
1
1, 1, 1, right?
Yes, ma'am.
So in the place of
Ma'am, not audible.
Ma'am, you are not audible, ma'am.
am I audible, students?
Yes, ma'am.
And now you are audible.
Ma'am, not audible.
Ma'am, you are not audible, ma'am.
Am I audible? Hello,
Yes,
students.
ma'am.
Am I audible?
Yes, ma'am.
Yeah. What about meet? Meet of MR1 in MR2. This will give you 0,
Ma'am,
1
0
0
1 0 0
1,
1 0 0
0,
0
0,
1 1
1, 1, 1,
1
0.
0 0.
0.
So you're getting this one, right?
Yes, ma'am.
For this one, matrix corresponding to R2 composition with R1. Yes? What I told you, matrix corresponding to S composition R will be
MS Boolean product MR. No, ma'am, sorry. MR Boolean product MS.
MR Boolean operator product with MS, right? So this one will be MR1, right? Right hand side is R1. So MR1 is written here with MR2. Clear? Okay. Tell me about this one. MR1 with MR2. Take the Boolean product. Yeah. This one will be rated with this one. 0, disjunction, 0, disjunction, 0. Clear? It will be
Yes, ma'am.
0. Then 0, 1, 0. Disjunction will be 1, right?
1.
0, 1, 0.
1.
Then it is 1, 1, 0, 0, 1,
Ma'am, 1.
1, 1, 1. That will be 1, 1, 1. Right? What about this one? 0,
0.
1, 0. Clear?
Yes, ma'am.
Similarly, calculate MR1 matrix corresponding to R1 with this composition with R2. R1 composition with R2. This will give you this matrix, Boolean product with this matrix, right? Okay. I hope that you can calculate. Now come to D part. Anyways, this was not given, and if it is asked, you can calculate it. This will be MR2 Boolean product with MR1. Okay. What about D? R1 composition with R1. Yes. R1 composition with R1.
And Boolean product of R1 with itself.
R1 with itself, right? MR1 with itself. So what it will be? So this will be MR1 Boolean product with MR1. This one with this. So here 1, 1. First entry will be 1. This one with this. So we have at second position 1. So conjunction of 1, 1 will be 1, and disjunction with 0. Disjunction of 1 with 0, this will be 1. Then this with this one. Second position we have 1, 1. So 1. Understood? Then this one, second 1, 1, 1 with this one. So you got what you got? 1. Second with second, 1. Second with third, 1. Now this one. Third with 1, 0. Clear? This one with this one. This one with this one. Then this one with this one, 1. This one with this one, 0. Are you getting it?
Yes,
Yes?
ma'am.
Yes, ma'am.
So this is MR1 square. Also you can just say MR1 square. And this will be second Boolean product of, that is MR1 2 times Boolean product of this one. Right? Yeah. What is this operator? This one. Yes? This is XOR. Exclusive OR. Right? And how it is defined?
If
If A and B
are
are 0,
there,
right? A exclusive OR with B, this will give you, it is 1 when
are present or no, none of them are present.
yeah, exclusive OR means either A or B, right? Either this is 1 or B is 1, but not both, right? Both should not be 1 at a time. That means whenever both those are not equal, either A is 1 or B is 1, right? Not both. So whenever not equal case, it will be 1, right? And in case of equality, either both are 0 or both are 1, it will give you 0. Understood? So matrix corresponding to this one will be R1 Boolean operation with MR2. This will give you the same operation, XOR MR2. What are you getting? Yes? What are you getting? Here to here?
Ma'am, 0, 0, 0.
This one with this one. 0, 0, 0. Right? You have A
Yes,
and
ma'am.
B are same for first row. For second row, 1, 0 will give you 1, 1, 1 will give you 0, 1, 1, 0. Then 1, 1, 0, 1, 1. Clear?
Yes, ma'am.
Any doubt?
No, ma'am.
No.
Related to matrix. Yes? No? Okay. Come to next section. This is equivalence relation. We have classified relation as a relation defined on set A, that is the R relation is the subset of A cross A, right? Okay. We have classified as reflexive, irreflexive. Irreflexive, I didn't give you that definition, right? This will be role A is not related to A. That will be irreflexive. And symmetric, antisymmetric, asymmetric, asymmetric also I didn't give you, I think. And transitive, right? Out of that, if a relation on set A is reflexive, symmetric, and transitive, all three at a time, then it is known as equivalence relation. What is the meaning of reflexivity? Corresponding. Corresponding. Yes? Corresponding.
I'm reflexing.
Asutosh Ranjan, wait a minute.
Okay, ma'am.
Okay. Akars Vatstrans. Akars Vatstrans. Abhishek Patnaik. Abhishek Patnaik. Achyut Chaudhary. Adas Patel. Adas Patel. Adas Patel. You're not audible. Yeah, what do you understand by reflexivity? Aditya Narayan. Aditya Narayan. And you're sleeping, right? Good. Aditya Ranjan Nayak. Aditya Ranjan Nayak. Akanksha Srivatswa. Akanksha Srivastav. Alay Kumar. Anisha Rai. Anjali Priya.
Yes, ma'am.
Okay, tell me the reflexivity.
Ma'am, reflexivity is like mirror image if A is equal to A or B is equal to B. Both have
Yeah.
same image.
Means A is related to A.
Yes, ma'am. And B is
Right.
related to B. Yes.
Means for all A comma A belong to R. That is reflexivity. What about
Yes, ma'am.
symmetricity?
Ma'am, like A is equal to B, then B is equal to A. A belongs to B,
Not
then B
equal to.
belongs.
Equal to is a particular kind of relation you are saying. So you can just say if A is related to B and B is related to A.
Okay,
Okay.
ma'am. Okay.
Then, sorry. If A is related to B, then you can say B is related to A. This is symmetricity.
Okay.
Okay.
Yes, ma'am.
Ankit Adak. Ankit Adak. Anis Sahu. This is Asis Sahu. Asutosh Ranjan.
Yes.
Yes, Asis Sahu. Tell me transitivity. Asis Sahu, unmute your mic and tell me transitivity. Asis Sahu. See, whoever are not is responding, I'll give this report to upper authority, okay? Okay, Asis Sahu, I'm marking you as absent. Asutosh Ranjan. Tell me transitivity.
In transitivity, A comma B belongs to R and B comma C belongs to R. Then if you find that A comma C belongs to R, then
Yes,
we say
A, B
that
is related
the
to A,
relation is transitive.
B is related to C, then you have A is related to C. Yes. So if a relation satisfy all these reflexive, symmetric, and transitive, that relation becomes equivalence relation, right?
Yes, ma'am.
Now, if any relation becomes equivalence relation on set A, then two elements are related, right? If two elements are related via this equivalence relation, then we can say these elements are equivalent, right? A is equivalent to B. Okay? If A and B are related via this equivalence relation, this is equivalence relation, then A is equivalent to B and its notation is this one, right? Now we need to show that congruence modulo M, the relation R, is given as A comma B, A is related to B, where if and only if you have A is congruent to B modulo B mod M. Okay? Clear? This is your congruence modulo M relation given. So this relation, you want to check whether it is equivalence relation on set of integer. So this relation is given on set of integer, means A and B are coming from integer. So check it. Is it equivalence relation? What do you check? Reflexivity, symmetricity, and transitivity. Okay. So is it reflexive?
Yes. Yes, ma'am.
Why is it so?
Because
Ma'am,
A
A
equal
is
to
congruent modulo of A.
Yes.
Related with the other elements of the equation.
Yes. A is related to A because A is congruent to A modulo M, right? And why is it so? M divides A minus A. 0, right?
Yes, ma'am. Yes, ma'am.
That's why reflexive. And this is happening for all integers. For all integers, you have A is related to A. What about symmetricity?
Ma'am, it should be related. I mean, A comma B will be equal to B comma A. It will be related.
Again, I'm just saying it is not equal. A and B are related, then B and A should relate.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So A is related to B means to say in different relation it does not equal. It does not mean equality always, right?
Yes, ma'am.
So here in this relation, it is A is congruent to B modulo M. Now tell me, you want B is congruent to A modulo M. This means what? M divides A minus B, right? Actually, if A is congruent to B modulo M, then B is congruent to A modulo M. This is always true, right? So M divides A minus B,
Yes,
right?
ma'am. Yes,
This
ma'am.
means
Yes, ma'am.
A minus B is the multiple of M for
M.
some integer K. Multiply minus on both sides. You are getting B minus A is equal to M into minus K.
Yes, ma'am.
This is multiplication. Okay. Now my K is integer, so minus K is also integer. You are saying B minus A is multiple of M. So can you say M divides B minus A?
Yes, ma'am.
So from here, by congruence modulo M, you can just say B and A are congruent. Okay? Or directly you can just write from here to here. From here to here, right? This is inbuilt. Clear? What about transitivity? So this is symmetric
Transitivity.
as well.
Yes, ma'am.
Transitivity. In transitivity, A is related to B and you will take B is related to C. A comma C and B comma C belongs to relation. This means A is congruent to B modulo M and this means B is congruent to C modulo M. Right? Then what do you do? From here you
Then
have
A
M divides
is
A minus
yes,
B.
ma'am.
From here you have M divides
B minus C.
B minus C. Right? If
Yes,
M
ma'am.
divides X, M and M divides Y, so M will divide some of these,
Yes, ma'am.
right?
Yes, ma'am.
M will divide some of these. So M divides X, that is A minus B, plus Y, B minus C. So this got cancelled. B. So what do you got? M divides A minus C. And this means what? A is
C
congruent to A is congruent to
C mod
C
M.
modulo
C mod
M.
M.
This means A comma C belongs to relation. So we have chosen that AB and BC belongs to relation. Then we have shown that AC belongs to relation. That means this is the transitive. Reflexive done. Transitive done. Symmetric and transitive done. A transitive also explicitly you can write M divides A minus B means A minus B is some multiple of M. B minus C is some multiple of this one. Then add it. You will be getting M into sum of these integers, right? So A will be related to C. This means what? This is equivalence relation.
Yes, ma'am.
Okay. Any doubt?
No, ma'am.
I stop here. Thanks. Tomorrow I'll be starting with this one, this example. I'll be checking that divides relation is equivalence or not. Divides relation means A is related to B if A divides B.
B.
Okay. Whoever is not responding in the class, start to respond. Okay. Do not sleep in between.